Yeah, we will redo this one, yeah. Okay. Thank you for asking. So we load the relevant data set. Okay. It's about the population increase. Okay. And the simple question is very simple one is in the Kenya, the country, in 2007 the population is 31,336. The population in Kenya, the elephant is 36,260. Over the 5 years, it changed from this population number to this population number. So the question is, okay, how much it change per year? That's the question. So that's something you want to do that 2007 31636 and then multiply by some number you don't know. It could be 1.12 and it can be 1.03 and it can be 1.05 and it can be over 5 years. So this one would be 2008. This one would be 2009, 2010, 2011. Okay. And this one would be 2012. Okay, year. This will get you the number 36260. But we don't know them at all. We don't know this one. We don't. We just given the number. So you are looking at the average. Okay, how much it changes. So in average, you are looking at the variable to S. So that would be the power of 5. Okay, so that would be get you the final value into the population on this one number 36260 and then move this one to the bottom and take the power root of 5. Then you get the answer. And this will be the mean per year. Okay, if you multiply 5 times, it will get you this value. But I want you to answer my question is how much it changes per year in the mean. That would be 2.7%. That's answer for good. Okay. So you have to be something being able to compute. Okay. So specify how many years and make the division on the numerator is the later year, the denominator is the former year, the previous year, and the take the power root. And you can do the computation here, okay, using the calculator. Okay. It will do the job, but carefully to make a use of it. Okay, so let me try one more time. Yeah, there's no problem, then we got one probability. Okay, so to compute the value is make this one 36260 divided by 31636. Okay. And then take the power root It's another 1/5 to do the job. And you get the number 1.027. But you have to be, this is increased, so there will be -1. Multiply by 100 and get into the percentage sense. Alright. Alright, and then let's move on to another question. Yeah, you should see the note here for some review before you come to the exam. Please come, yeah, just follow up our syllabus, and then so yeah, come regularly and participate on second exam and do final presentation. Yeah, thank you. Alright, so the second question is compute the correlation. Okay. And this one can be done quickly. Okay, and the note is yeah. Why 1/5? Oh, alright, good question. Yeah, thank you for your question. Let me answer. So after you compute the average, it's 1.02, right? So that would mean each year you multiply 1.02 to the next year population. So yeah. So how much you change it? 2%. It's a 2% change, right? In this case. Yeah. So I -1 because I want to see how much percent it changes. But you can see automatically, you do not need to do something like this. Simply do this one, get you the intuition. This is a 2.7% increase. Yeah. And then want to quantify it by -1, and this one is 2.76%. So that's something we can see together. Thank you for your question. Alright, so any other question? Alright, if not, let's go to the beta. This is the data set. Okay. Alright, and I want you to do the 3 company for the correlation. Okay. So it is over here. If we look at the note, you can just looking up the correlation definition make a use the SPSS analysis correlate bivariate. That's it. And pick up the 3 company. You can have the Microsoft. Okay, Aston Mobile. Okay, Johnson. Alright, that's it. And then do okay. Yeah. And this is the table we are going to make a use of to answer our question. So let me try to explain. Based on the table, you can have based on the table, you can have alright, the value here. So what would be the correlation? Actually, forget about the SIG thing and the N thing. This is actually 3 value, 1, 0.061, 0.148. Okay. and also do the 0.0 step 1 on the second and the 1. Alright, no problem. Yeah. And this one is okay 0.143. And then finally, this one, it is a Pearson correlation. Just look at the Pearson correlation 0.148, 0.143, and 1. Okay, so this is the Microsoft M, this is the Edison E, and this is the Johnson. And the M, E, and Johnson. So you can see their correlation matches the. Okay. In SPSS, they do much more for you. They also test for the correlation is significant. It's really give it an impact. But at this time point, we don't do inference. We just show you something more. So which pair of a company high is the correlation? What would be this one? The pair has to be 2. So the biggest number is 148. So the highest one is MJ. It's a Microsoft, so the correlation is 0.148. And the lowest is okay 0.061 is ME. That's it. Yeah. That's all I want you to do. On the diagonal it's always 1 because the variable are perfectly correlated to it itself. Okay. So that would be the answer. Alright, so let me save the file. Yeah, it's just a data set, so you have to run the file for so on your side. Okay. And the rest of them are probability, then we can try them as well too. This is all doable. It's simply asking you to make a use the SPSS to compute the probability. After midterm, we will do inference, and there will be more general one to make a decision. Because data science has to be, as a manager, you have to make a decision based on the number.
What is the highest number now? 1.
Here? Okay, that's because it's totally identical. Right? That's a pretty good question. That's identical. Identical because this one, if we look at the notebook we have, yeah. The correlation has some definition with this one. Simply say verbally is you use the same data to compute their relationship. They should be unified, perfectly describe each other. Because when you are talking about cells, so when you move up, you really move up. When you go down, you really go down. Yeah, but when you talk about the two different companies, one can go up and one can go down. So that's why the diagonal equal to 1. And the off-diagonal is never equal to 1. Yeah, so that's the explanation. Yeah, good question. And all right, so let's move to another. Level here. Okay, so 26. Alright, so here we go. Yeah, 2 more lectures and you should be fine. make the note here. Okay. So it's just something I want you being able to make use the software. And there are much things inside the mathematical probability, but we just need to specify the parameter in the probability family. And here, what would you need to specify for this question is a binomial, and they have two parameters. One is n, the other is p. Okay, so answer the question. You need to specify the two parameters here. So that is make up this table. So for in the very beginning, you create a variable called x. Okay. Maybe I should do it together. This one's the binomial. BIN. Binomial. Okay. So in these cases, it actually count up to n. Okay, and here is 10. So you are going to make a use this one to 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And what would you like to do to compute the probability it has? So I want to compute the probability in it to transform. Compute the variable. And this one is the BIM, PDR2. That's a binomial distribution. So get the target the variable name, and you can specify the function with the PDF, computing the probability here. Okay, and the family member is the binomial. Okay. Then you want to specify the same. So do a 3 question mark. The first question mark is the variable value. Okay. So you move this one to the right hand side. And the second one is the n. Okay. N is 10. Because the question show you should specify n equal to 10 and probability equal to 0.35. That's it. Then you can get the probability accordingly. This is a 2-digit output. Look at how nice. But you can try to make it into 3. Make a little bit longer to see some value really happen. In 2-digit you see 0, which seems to be okay. Not so good. A 3-digit get you more reasonable value. Okay. So what does this mean? So that would say the probability none of 10 integer is PS equal to 0, and this one will be equal to alright, so this will be point 3, okay, and this one is P equal to 4, okay, 0.238, alright, and at least 2 is something you are going to do 1 minus B that's equal to at least 2. So you have a 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. At least 2 is get you this one. So if you minus that's equal to 0 and the minus p is equal to 1, you get the same answer. So it's 1 minus 0.013 minus 0.072. That's the answer. That's the complement for probability. Okay, this is at least 2, so you are actually computing. Okay. So this is equal to 1 minus. Yeah. Okay, so you pick up the two values, or you can add them up if you want to. Really up to you. Yeah. So give me this number, and you will get the answer. Okay. All right. That's the first distribution. And Poisson distribution will do the same thing. Yeah. It's doable. It's just specify the parameter in Poisson distribution. Okay. You will see. In per hour, it's a 7 suite. Okay. So the parameter is lambda equal to 7. Okay, per hour. Okay. So that is something you can say. And then we move to the Poisson distribution. Okay. But let's look at the question, the 4 of them. No suite. Okay, lunch hour. Okay, at least a 4 suite lunch hour. Okay, 1 hour. Okay. Yeah. And no suite, first 15 minutes. So you can try to change this one to divided by 4 is per 15 minutes. So the unit change, because 1 hour have 4 quarter hour, okay, divided by 4 you get to the mean. The first 30 minutes will be divided by 2. That get you to specify a different parameter. Okay, per 30 minutes. So what do you want to do? As looking up the number is no suite 0, 4 suite and 15. So do 1 by 1. Okay. Let me save the file. Okay, and let me do this one. And do the same thing. That would be the variable for. Okay, this is the POIS, Poisson X. And this one is measured with a scale. And you need to manually input the data here. No suite is from 0. Okay. And the 4 suite, okay, lunch hour. So you can do 0, 1, 2, 3, 4, at least 4. So you probably compute more, something more, okay. So 10 will be fine. That's what, based on the question we have is to do this one. Okay, so problem A, no suite to compute this one transform. Compute the variable, and you will do the same. And this is the PDF. Okay, POI. Okay, alright. Okay. It's the same thing here for Poisson. Yeah. Okay, so you can try to use it to do. We cannot see the PDF. Okay, pick up the family member is the Poisson here. double click. This is the variable, the value, the data. And this one is the lambda. You need to specify. So for the question A, it's during the lunch hour. So you specify, given by the condition, it's 7. So you put 7. Okay. Okay, so POI 1 per hour. Okay. Alright, and this one will be 7. Okay. So that would be no tweak as equal to 0. It does give you some probability. It's just the digit is not enough. You do 4 digits, it gets you 0.0009. Yeah. We'll try to show you to write up the answer here. So the probability s equal to 0 and the lambda equal to 7 is equal to 0.0009. That's the question we try to do. And at least the 4 is the same thing. Is you can do the greater equal to 4. Okay. This one is equal to 1 minus that's equal to 3. So it's equal to 1 minus b equal to 0. One, 2, 3. So that would be equal to 1 minus 0.0009. You can do this one. Minus 0.0064, minus 0.0223. That will get you the answer 0, 1, 2, 1, 3. 0.521. Okay. That gets you the number. Is yeah, that will get you the 0.9183. That's the number you can do. But you can also compute the CDF, something like that. You can do something, but this one is a CDF to sum up to the point. Not necessary, I won't ask you too much to do the computing using complicated data, but CDF solve the problem. It sum up to the data. So this one is the point. So here. Okay, that's a distribution. Alright, so you see, yeah, 0.09. If we get the more digit, yeah, it's exactly the same. It's up to this one. So you are going to 1 minus this one to get the answer. Yeah. Up to you. You can pick up each data point to compute the probability, or you can try to using CDF. Okay. Yeah. All right. On the 2 more questions. Yeah. Let me try to. Okay. Review it. Okay. Save the file. Right. And that would be the notable upload. Alright. Okay. Yeah, the final one. Hopefully. Okay. Alright. That's a continuous case, but this one have to do the same thing, but this one we always do CDF. Okay, we always do CDF for uniform, for the uniform, for the normal, okay, for exponential. So let me try. Okay, so let me do this on the new one. Okay, so how to do this based on the question is the saying the flight time is 2 hours and 5 minutes. So that would be 1 to 5 minutes. Okay, generally. And you believe uniformly this is distributed between 2 hours, so that would be, fastest one would be 120 minutes. The lowest, the slowest one would be 140 minutes. And the mean is in average here is 125. So no more than 5 minutes later. Okay, so that would be asking you for the S. No more than 5 minutes, that would be say 125 plus 5. Because you are claiming that my flight can be due in 2 hours and 5 minutes, but it cannot over than 5 minutes. Okay, later. Okay, so this will be computer probability here. So which is 130. Okay. Alright, so how to compute this one? And then more than 10 minutes later, it would be greater than 10, it's greater than 135. So how to compute this one? Okay, so that would be, you can try to say, create a variable called the time. Okay, and then scale. Okay, and you specify the minimum of 120, and specify 125, and specify 130. Okay. Okay, specify the 140. And you are going to make a use of it to compute the variable by CDF uniform. Okay, and then do the CDF and do the uniform. Okay, and the time variable here, the minimum, the parameter is minimum 120, the maximum is 140. Okay. So after that, okay, we get its value. So how to compute it is no more than 5 minutes later, it's smaller than 130. So that would be this value, CDF 0.5. Okay. Okay. Oh, we have added one more called 135 and 140. Okay. Okay. Yeah, apply again. Yeah. Alright, so do it again. You get the value. So greater than 135 equals to 1 minus probability smaller than 135 is equal to 1 minus 0.75 equals to 0.25. It's okay? Yeah. Does this make sense to you? We have a lot of more questions on, it's almost time up. Let me ask, how about let's just do the question at this time point, and we don't do the exam for the normal distribution at this convention. Yeah, yeah, that's too much. Yeah, so so we don't do the rest of them. And let me wrap it up everything to get you ready. And the video will be uploaded soon, and the announcement will be uploaded after the video is successfully made up. Okay, so all right. Okay, so let me do here? Okay. So I can write up some note here. Say return. Okay. 2025. The upload 15 and time is let's do 9. Please come on time. So let's do 9:20 to noon. Okay. So you can download the file between 9:20. Okay. And the 9:30 a.m. and no internet after 9:30. Okay, so use SPSS to solve the problem. And then write up your work on paper. Draw the clock and table. Answer the question. That will be good. Yeah, that's all we can try to show you. I hope this is acceptable. And then we're trying to show you some training on data science. This one, after you are comfortable using SPSS, you will know what to do. Okay. All right. So finally, let me wrap up everything and upload to the Island 2. Okay. Okay, good. And because I want to do the exam, so we don't do the raw code today. Yeah, okay. Yeah, to be consistent for everyone. If you consider it to be fair with you, or you can let me know. Yeah. Okay. Right. So okay, let me come. Okay. Right. Okay. So that will be all my solution. But more importantly, and these are the data set. And more importantly is the note here. Yeah, please refer to the note. I wrote up something but do not have time to reorganize it. You can try to check out my question over here. You can download it during the exam and then try to compare the question and the solution here. Right. Okay. We will make up the announcement later. Thank you for coming. Appreciate it on the midterm time. I look forward to see you next Wednesday at 9:00. Thank you.